So I'm going to look at the solutions for the chapter 14 homework. The first problem was number 14. It actually cited problem number 12. So to begin with, I just thought of what probabilities I needed. So I needed to know just how many people were in each category. So chat problem 12 had told me that 55% of the students had never had calculus, that 32% had had one semester, and the rest had more than two. So I just took these two numbers and subtracted them from 100%, and that's how I got my 13% for more than two. Now the question asked, the first one, is the probability of having two people in your group who've never had calculus. So I have one person and another. Now this and is really important. That comma represents and there, because that means I'm going to be multiplying the two events. So I just did the 0.55 from right here and did it twice since two people and got 30.25%. Now the second problem, B, is a little bit more complicated. Both have studied at least one semester. So they both have studied at least one semester. So for this one, I've got that the first person has 1 or 2 semesters, because that is at least one semester for the first person, but they both have, so the second person also has 1 or more semesters. Okay, so this makes it kind of a two-part problem, because what I have to first do is figure out what 1 or more is, and that is or, which is plus, so I add 1 or more, which was the 32, and then the 0.13%. But then I also have to multiply it, because these two things are, there's two people, so two events with the and. And so I multiply it with the other 1 or more, where I added those in parentheses. When I do all of this, I end up with 20.25%. That problem is definitely a bit complicated. Now for C, I have another one of at least one, but this is a little bit different. At least one person. So one of the two, I don't know which one of the two, or it could be both, have had more than one semester. That means that I could have one of the first person could have 2 semesters, or both people could have 2 semesters. That would be a 2 and a 2. Or the second person could have 2 semesters. So there's a lot of scenarios. The easier thing to think about is what's not happening. The one thing that cannot happen is that neither of them have less than 2 semesters. So that's when I think of using the complement. So right here, we've got the probability of at least one having more than one semester. So that's going to be 1 minus what cannot happen, the alternative, which is that the first person has less than 2, which is 1 or none, and the second person also has less than 2, that's 1 or none. So again, I have quite a bit to do here now. So I'm going to do 1 minus the first person, which I have to actually combine these because it is 1 or none, times the second person, which I also have to combine because that's 1 or none. When I do all that, I get 24.31%. Number 23 is about M&Ms. So the first thing I do is I just figure out what all of my probabilities are right up here. See? So if we look up here, you can see that they told us all of this ahead of time. What I don't know about is brown. So A asked me how many browns. That's the only one. So it's basically the complement. It's 1 minus all the stuff they already told me. So I just simply do 1 minus all of these added together, and I end up with 30%. So brown is at 30%. Part 2 asks if it's yellow or orange right here. So yellow or orange, that or right there tells us it's addition. So I just add those together and I get 30%. Part 3 asks not green. Now, not green, that is a complement. So when I have a complement, I could just do 1 minus the probability of being green. 1 minus 0.1, which is 90%. Part B has a little more to it because now I'm picking 3 M&Ms. They want to know a chance of getting 3s that are brown. So that's brown and brown and brown. That comma again is showing me the and. When we have and, we multiply. So 0.3 times 0.3 times 0.3, and that gives us 2.7%. Number 2 is the third one is red. That means the first one's not red. The second one's not red. And the third one is red. So the probability of not being red, well, that's going to be the complement of being red. Red is 20%. We see that right here. Okay. So not red is going to be 0.8 times 0.8, and then red finally is that 0.2, and the answer ends up being 12.8%. On 3, they ask us about choosing none that are yellow. So that's a not yellow, a not yellow, a not yellow. Well, the probability of yellow was 20%. We saw that right up here. So a not yellow would be the complement of that, which is 80%. So I'm going to have 0.8 and 0.8 and 0.8. Again, and is multiply, and it gives me 51.2%. The last one is that hard problem with the at least. So notice my probability statement, probability of at least 1 green. Okay, that could be 1 green, 2 greens, or 3 greens. That's a lot to think about. So I'm going to do the complement, which is what cannot happen. The alternative to having at least 1 green is actually having no greens. So I'm going to look at just 1 minus no greens, and that will equal the at least 1. So I just do 1 minus. The probability of not getting a green is 0.9. So the probability of getting one is 0.1. And just multiply all those together, subtract 1, and I end up with 27.1. The next problem is number 27. So this is rolling 6s. Okay, so we're going to roll 3 die. And A looks at the probability of rolling 3 6s in a row. So that's a 6 and a 6 and a 6. Again, my little comma is the and. So I multiply that. The probability of a 6 is 1 out of 6. Multiply it 3 times, and you end up with, this is not right, 1 6 times 1 6 times 1 6. That should be a 0.46%, I believe. On B, they ask the probability of an odd roll. So that's an odd and an odd and an odd. Again, we're multiplying because of its and. How many numbers are odd? Well, on a die, the odd numbers are 1, a 3, and a 5. So that's 3 numbers. So it's 3 out of 6. So we have 3 out of 6 times 3 out of 6 times 3 out of 6, which is 12.5%. C asks none of your rolls get a number divisible by 3. So here I need to think for a second. And what I know is that if none are divisible by 3, let's see here. What numbers are divisible by 3? Well, 3 is divisible by 3 and 6 is divisible by 3. So that leaves us 4 numbers that are not. So not being divisible by 3 would be 4 6. So this is D here. But if I get 3 in a row that are not divisible by 3. So that'll be 4 6 times 4 6 times 4 6, which is going to be 29.63%. Now for D, this should be a D here, excuse that. For D, we have the probability of at least 1 5. Okay, that at least word again. Okay, we know at least, that means things get complicated because I could have 1 5. I could have 2 5s. I could have 3 5s. Okay, that's a lot to think about. So what cannot happen? Well, what cannot happen, the alternative is no 5. So I'm going to focus on that because that's just one thing. So looking at the idea of no 5s, and if I subtract that from 1, I'll actually know the answer to that at least. So I just do 1 minus the probability of no 5s is 5 out of 6 times 5 out of 6 times 5 out of 6, and you get 42.13. I didn't write it here, but we have the number you rolls are not 5s. So that's just going to be the probability of not 5 and not 5 and not 5. And to do that, it's actually this right here, right down here is that not 5 thing. So if you just multiply these 3 things together, you'll actually have your 3 not 5s. Moving on to number 29, bowling. Okay, so what I like that I did here is first thing I did was just write down my information, right? Probability of getting a strike is 0.7. So the probability of not getting a strike is 0.3. So the first question asks, what if you go 3 frames in a row without a strike? So that's an and, so a no strike, and then no strike, and then no strike.